Hello, this is Steve. In this session, I will tell you Genian NAC detect and control the device. First, let's look at how Genian NAC detect the device and register it as a node. By default, when a PC connects to a network, the PC uses the ARP protocol to communicate with other devices. The ARP protocol is that when new device connect to the network, new device introduce MAC and IP address to the other devices in the same subnet and request the information who is using the IP and MAC address to communicate with other PC. If the receiving the IP and MAC information from other devices to update the ARP table on MAC and IP address matches, and the device report to the ARP table when the device need to access with the other device. There is a PC, for example, there is a PC with 10.1.1.1 IP address and AABBCC DDEF MAC address. The PC wants to know the other PC what has the IP and MAC address. The PC sends the ARP packet to the entire device, then use the same network subnet to communicate with the other PC. If the other devices that receive the packet from the 10.1.1 IP PC, the other device send the ARP response packet include their IP and MAC information to 10.1.1.1 PC. 10.1.1 PC receive the ARP response packet and update on ARP table that 10.10.10.2 IP is use the ABCDEF MAC address. The next time the 10.1.1.1 PC need to communicate with the 10.10.10.2 device, it communicates directly to access the ABCDEF MAC address by referring to their ARP table. And let me tell you how the network sensor detect and register node when the new device connect to the network. When a new device connect to the network, the device deliver ARP broadcast packet to the communicate with the other PC. You can see the number 1. And the network sensor receive the packet, detect the new device, and register the device IP and MAC information to the police server. And police server command to the network sensor to scan for the new device. And police server check the network sensor with active scan for information such as platform and open port or etc. information for new device. And for the network sensor forward the collected information to police server. And lastly, police server use the information gathered to classify the device type. It is the PC or printer or switch or router or something like that. And it is the ARP poisoning, how to block the node from the network sensor. When a node A connect to the network, node A send the packet to all devices on the same network subnet with each information to ARP broadcast. Every device sends its information to node A with an ARP response packet. Node A updates each ARP table information. If node A is blocked, the network sensor modulates the ARP table in node A by sending an ARP poisoning packet to node A with 1.200 IP address. MAC address has AAAA. It is the network sensor MAC address. When node A attempts to communicate with node B, all packets are passed to the network sensor, and the network sensor that receives the packet drop the packet or reject. So the node A PC couldn't communicate with other network device. Yeah, if we look at the ARP table on 1.23 and BB MAC address PC, and the PC had that ARP table. It is the normally. Each IP address matches each MAC. If the 1.23 PC is blocked, you can see that all MAC addresses in the ARP table are changed to the network sensor MAC address. And this is a picture that shows how your PC is redirected to the CWP guide page when it is blocked. When a PC is connected, the network sensor modulates it. All of the PC ARP table through ARP poisoning to the network sensor MAC address. So when the PC query the DNS to get the Google URL web IP address, the network sensor queries the DNS server for URL information on behalf of the PC. And the PC that received the destination IP for Google send this TCP sessions, and PC send the TCP session SYN packet to the Google web server, but communicate instead as if network sensor were a Google server. After TCP session established, the PC sent an HTTP GET packet requesting a web page. At this point, the network sensor sent the address of the CW page to the PC, which redirects to the PC to the CWP page. We've learned how network sensor detect and control node.